Okay, you're welcome back to Introductory Mathematical Analysis A. We are still in chapter 13, and this time around we are going to be going to chapter 13.2. Okay, in chapter 13.2, we are going to be dealing with absolute extrema on a closed interval. Absolute extrema on a closed interval. That's what we're going to be dealing with in chapter 13.2. Okay, absolute extrema on a closed interval. Okay, absolute extrema. Don't forget this extrema I mentioned to you is maximum. So we are dealing with absolute maximum or absolute minimum, or both of them. In fact, here we are going to see, as we are going to see from the extreme value theorem, that here on a closed interval, let's assume it's from 1 to 4. If we are finding the extrema on a closed interval, then we are going to have a maximum there, and then we are going to also have a minimum there. Okay, so this closed interval can also be written as this. This closed interval can also be written as. So when we write this with a square bracket, it's a closed interval. Open bracket is not a closed interval. This means 1 is not included and 4 is not included. But here 1 is included, here 4 is included. All right, so let's take this extreme value theorem. So we have, if a function in this theorem, the theorem says if a function is continuous on a closed interval, then the function has a maximum value and a minimum value on that interval. If it is closed, if the interval is a closed one, then the function will have a minimum value there and a maximum value there. Okay, let's take this graph. You discover that this is closed. Closed means it's shaded. Don't forget that. Close. And then we have, this is the lowest point in this function, and this is the highest point. So this is the highest value, and this is the lowest value, or the minimum value. The maximum value, the minimum value. The same thing here is a closed interval. So we will have the maximum there, and then we have the minimum there. All right. So let's see how we can solve problem on this whenever you are asked to find an extrema in a closed interval, which is called absolute extrema in a closed interval. So the first thing we need to do is to get the critical values. And to get the critical values, you need to find the derivative first. Find the derivative and get the critical values where f of a is equals to 0, f prime of a is equals to 0, or where f prime of a does not exist. Don't forget that. Does not exist. Okay, then after finding that, we need to evaluate f of x at endpoint AB. And at the critical values. So we evaluate f of x at endpoint AB and at the critical values. So the maximum value of f is the greatest value found, and then the minimum value of s is the least value found. Okay, that is how to deal with a problem involving a closed interval. That's how to find the extrema involving closed interval. Okay, let's take an example. All right, so now we want to find the absolute extrema for this value over the closed interval. Don't forget, this is a closed interval. This is the function given to us. So the first thing is to find the derivative. The derivative of that is 2x minus 4. That is the derivative of that. What is the next thing? The next thing is to equate the derivative to 0. Equate the derivative to 0, which implies 2x minus 4 equals to 0. So 2x equals to 4 and x equals to 2. All right, that x equals to 2. So let's look at the derivative. Do we have any point of x that will make this derivative not to exist? Of course, there's no point. All right, so the only critical value we have is that one. So the critical value is x equals to 2. All right, now we need to evaluate f of x at this critical value and at the endpoint. So we want to evaluate f of 2, f of 2, f of 2. Okay, so let me bring that down a little so that you can have that. Yeah, we want to find f of 2. F of 2 is 2 raised to the power 2 minus 4, 2 plus 5. Okay, that is f of 2, which means this is 4 minus 8 plus 5. Okay, this is 1, equals to 1. Now we need to evaluate f of 1 also. Don't forget that is the endpoint. We need to evaluate at the endpoint also. So we evaluate at the endpoint. We evaluate at the endpoint. So we have 1 of that, 1 square minus 4 times 1 plus 5. Okay, this is 1, this is minus 4, this is 2. Then we also evaluate at 4. So to give us 4 square minus 4 times 4 plus 5. Okay, 4 square is 16 minus 16 plus 5, which is equals to 5. So you see now, from here now we need to find what is our maximum. This is our maximum value. Okay, and this is our minimum value. That's our minimum value. So you see, in this one, whenever we are dealing with closed interval, extrema in closed interval, we just need to find the derivative, equate the derivative to 0 to get our x, and check if there's any point that will make the derivative not to exist. If there are, then you include it in the critical values. If they are not, then the x here is the only critical value. Then you evaluate each of them. You substitute each of them into the function to get your values, and then from there you get your minimum value and your maximum value. Okay, please ensure that you understand. Okay, that is all what we have done. So that is all what we have done. Okay, so this is the maximum, while this is the minimum. Maximum and then minimum. Okay, please make sure you understand. Ensure you understand. All right.